Example 20.5, we're going to get to see some creative side of use with logarithms. It says here, let log base b of 2 be equal to the capital letter A. Log base b of 3 is going to be equal to the capital letter C. Write each expression in terms of A and C. So this means that I don't want to have any logs actually in my expression anymore. I want to be able to replace it with the appropriate A and C as they appear. Now, the only way that I can get A to show up is if I have this statement log base b of 2 appearing. And the only way to get C to show up is if I have log base b of 3 appear in my statement. The first statement that we have is log base b of 6. Neither one of the given statements that I was provided with are log base b of 6. But there is a way that we can get creative here with this argument. The argument does not have to be left as 6. It could be represented as a product with 2 times 3. And if I represent it as a product, then I can use the product rule to expand the statement log base b of 2 plus log base b of 3. In which case, the log base b of 2 we know is equivalent to capital A. And then the log base b of 3 is equivalent to capital C. So log base b of 6 does actually have a log base b of 2 and a log base b of 3 built into it. We just had to creatively get there, and this allows us to now say the statement is A plus C. Another example of this next one's going to be a little bit more involved because the manipulation of the argument may not be as obvious as it was in part A. And maybe in part A it still wasn't very obvious. This is definitely a high-level problem-solving skill here that we're working on. So the argument on statement B is the entire square root of 3 divided by 16. Now I would encourage you to challenge yourself and try to work through this one on your own. I've worked this example in class for years, and every time I work through this, it seems as if the class has come up with a new way of getting it done. So what I'm going to present to you here is just going to be one of 3, 4, 5 different ways that you can get this accomplished. And they all eventually get to the same place. There's just different ways to get there. So it really depends on how you see the argument and how you see it simplifying and then expanding and breaking up. So when I see this, I always try to simplify the argument first before I do any kind of expanding. So the first thing that I would do is I would think about this square root as applying to the numerator and also applying to the denominator. There's a property of radicals that allows us to be able to do that. Now that's really convenient, especially for the denominator, because the denominator is going to have a nice square root. That's going to be just 4. But since the numerator does not have a nice square root for 3, I'm just going to leave it represented as the square root of 3. And that would be as far as I could take the simplifying of the operations that are in the argument, which is the radical, and then I can't do anything with the division as far as simplifying. But I can get into expanding now. The square root of 3 is my numerator, 4 is my denominator, and this is going to become log base b of the square root of 3 minus log base b of 4. We saw in previous example where the square root of 3 can be rewritten so that way it has a power. So we can rewrite that as 3 to the 1/2 power. And I can also rewrite 4 as 2 to the 2nd power. Now here's where there's deviation sometimes in In a classroom setting, sometimes people will think of this as a product, 2 times 2, which is perfectly fine. You can think of it as a product, but since we were just working with a power for that 3, I thought, why not just do another power? So now I can take the 1/2, pull that in front of the first log, and then take the exponent of 2, pull that down in front of the second log. So that's going to give me 1/2 of log base b of 3 minus 2 times log base b of 2. And the whole point was to somehow get to where we would get a log base b of 3 and a log base b of 2 to appear from this expression. And that's exactly what we've done. So now I'll replace each of those with their respective letter. So this is going to say 1/2 times c minus 2 times a. And that gives us our expression in terms of a and c.